in a little bit. Let me know if there's any issues with the audio or stuff like that. Um, but yeah, I believe this was a uh, question that arose in the Discord. Um, it just took me some time to get prepared and stuff for it. Woody Baum, you made it. You're on time today. Jabram, how's it going? Yo, 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 yo. Yeah, there's also some suggestions about the chat window. I'm going to go with no music today, see how it goes. Um, I know some people get nervous about the real estate or the screen UI, like the chat window takes up space. But I don't know, I'm partial to having the chat window up, just so the recordings, like people on YouTube and stuff, can somewhat follow along. They just don't get left behind, or they don't know who I'm talking to or something. So yeah, I think No Genome. Thank you for the 3 months. Twitch Prime. Let's go. Let's go. Yeah, and we also had Nell Piper subscribed at tier 1 during the off hours, the office hours. Duck Plan, how's it going? Yeah, I think it was TM13 asking, where was it? Here it is. Asking about retiming pyro effects. Said the method, which I know is not very efficient. I can't use it all the time. It would be very nice to give a demonstration. I'm not going to do the car burnout smoke, just because it's like a heavier cache. There's a few examples I've prepared. It's kind of different scenarios and different situations and stuff like that. And then I think this one, I picked the flamethrower one a little bit just because it has more fields than just density. So you have other fields that you use to color the volumes and stuff with it. Binzal, QQ. How's it going? Steve GH, how you doing? Your internet is still full strength? I was reading, or a bunch of other people had complaints about the Optimum service or whatever in New York. They were dropping the ball. Said it's not a super drastic retime. The retime SOP can interpolate fields okay. If you had some pulsing or flickering, you might need to try. Oh, that's what I had typed in. Please demonstrate it. Yeah. So we'll get take a look at that. So yeah, we'll just go right into it, I guess. There's this file that I started to prepare. Can do. Let's get into the macros. All right. So this is the scene I have open, or I'm working with right now. It's pretty simple. So I just made this pop source or whatever with some variance or some noise to get it kind of like shooting in a direction. Most importantly is just like the velocities for everything. Black Cuckoo, how's it going? And then the Pyro source, so this is just adding extra attributes for the Pyro solver to source. So we have a temperature, density, and divergence. Divergence is, we're using it at the start of Houdini 18.5 with that stream, just talking about how it will expand, like spread out or grow over time. September, I'm hanging in there. How's it going? We are almost fully locked down again here in San Francisco. I think most of California maybe. All right, this is trying to simulate or something. So yeah, this is just adding, we'll make this a little bit clearer, attributes. And then volume rasterized attributes is what actually bakes these attributes into extra volumes. So just according to this list, there's some settings here for just controlling the rasterization process. And then just using this Pyro solver, this is like with 18 or 18.5, they've been added, I think they added it in 18 and then they've been improving it. So it's pretty nice now. It has the minimal OpenCL, all of that stuff. I'm using it in the sparse solving mode. So I don't have the OpenCL stuff turned on right now. And I did a cache, and for retiming effects, one of the things I usually don't cache out is velocity, but for retiming, velocity can be pretty helpful or pretty useful to keep this around. The reason being is that the time blend node has a method called advected that will use the velocity field to interpolate between frames, if that makes sense. So we could try doing just like both of these at once. Let's move one of these up like two units and merge them together. So this time blend, I'm doing it by vel. And then this time blend, you're just making a big mess here. This time blend is just by voxel position. So this doesn't require velocity. It's just like if you're blending two images together, it's just like cross-fading them every other frame or whatever to interpolate or to blend between them. Black Uku, thank you for the 4 months. Twitch Prime Gaming. So on the top, we have the time blend by voxel pose, and on the bottom is the advected method. And we'll just make sure, so resolution is turned off, and should be good with it. You just close my existing flipbook, and we'll get started with just a fresh one. So I've pushed these time blends pretty far. I'm doing 0.1 in terms of speed, so like 10% of the actual simulation. So I know in the question, TM13, they were saying it's not super drastic. This is more of a test to kind of see how far you can push things. So up top, you can see there's more artifacts doing the blending by voxel position, because there's no motion interpolation. It's purely just positionally, like fading one in, fading one out, if that makes sense. And on the bottom, it's a little bit better. There's still some issues. This is a case where it's like pretty drastic, but there's never really going to be a great way to handle this. Like, this is, from my experience, this is the best you can ask for in terms of a quick interpolation method. If you're really interested in like going crazy with the retime and getting really drastic stuff, yeah, the bottom one is smooth. There's still some issues you can see. There's still some flickering because everything is based off of like you just have input frames that are too far apart. So you do get a little bit of like flickering and issues and stuff like that, but it's overall it's definitely a lot more stable. So we just did 10 seconds or 240 frames, and then both of these I just did the speed at 0.1. Let's do another advection here. This one I'm just going to do 0.25. So this will be a quarter of a frame, or four times as slow, essentially. And let's keep using this transform. And then I'm going to try doing a time shift. Let's do this. You just do FF, usually if you want to keep doing like non-integer or floating frame number. I'm going to try doing plus 0.125. So that should be 1/8 of a frame. You could also do like 1 divided by 8. That should be the same thing. If you're worried about decimal, the math not doing decimals or whatever, you could just do plus 0.125. So what I'm doing here is shifting 1/8 of a frame over. And let's see what happens. So it's still getting a good amount of strobing. I don't know how much it helped doing my small offset. Sometimes if you do like a half, if you're on quarter frames and then you time offset stuff by a quarter, or I'm sorry, 1/8, you can get rid of like some of the strobing, because instead of one of the issues with like retiming with quarter frames, or if you simplify it down to like going half speed, you're starting on like frame 0, which is the best scenario because you're reading the file from disk and then you're just not even retiming it. And then for the next half frame, you kind of have the worst situation because you're kind of blending between the current frame and the next frame. So you have the worst output. Then you go to the next frame, and then that's like frame number 2, and that's the best situation again, because it's just 2.0 or reading and writing frame number 2. So you get pulsing because you're going from basically the raw simulation output to a interpolated or like a made up frame. So just offsetting like I was doing here by 1/8, or to get yourself off of integer frames, that can help avoid some pulsing or like differences in quality sometime. Looks like it's not super apparent with this one. It might be like a little bit, just a little bit better, but it's kind of hard to tell. So that's an idea. Let's just try it going with half frames, and then I'm gonna advance this one or shift offset by a quarter frame. So does that kind of make sense with doing an offset like that for just to get yourself off of integer frames? So you're basically, this top one up here is going from, should be going from frame 0.25 to frame 0.75 to frame 1.25 to frame 1.75, and you're always displaying like something that's interpolated by the same degree, or it's always this, these results are always the same distance from a full like perfect result, whereas the bottom one is going from like a perfect result to the worst outcome, which is perfectly blended or halfway between perfect results. So let's see if this one's a little bit. Some of the stuff up at the end of it is looking a little bit smoother than the bottom one. It's kind of gets rid of like some of the really high frequency strobing. Maybe if you just isolate like the green channel and stuff, you can tell a little bit better. So just doing that quarter frame offset to get yourself off of like disalign yourself from integer frames can help quite a bit. So I think like, especially when you're interpolating temperature or stuff that you're ramping, like there's visualizations baked into this stuff that's applying a color and luminance or brightness ramp based off of these values. So that can really boost like small artifacts or fluctuations in the field value. So if you're interpolating things, you have to be pretty careful about even introducing like subtle differences with smoke. With raw density, like I was saying, if I was to just do the tire burnout scene, it would be less apparent, like subtle differentiations in the field values, because you're usually just re-ramping smoke, or you're just visualizing it as like a pretty uniform value. Like it's just how much soot is in the air, so it's just some opaqueness or opacity. But retiming fields that you're going to then render with ramps, color ramps and brightness ramps, and pretty drastic like remapping, that's something you have to be pretty careful of with the actual like values you're putting in. So you can see there that's getting like strobing, and then we just do our offset. So we change the frames a little bit to fix it up here. So hopefully this is helpful. I have a few more examples I'll get to. Let me just try to put together a little bit better of a visualization. Some of this stuff, it gets pretty technical. So having some good strategies for like debugging things can be pretty useful. So in this case, I'm just going to do a font. And I think we can just merge it in with our main stream. So the font node, if you just leave it at the default settings of frame, like $F right there. Sometimes I switch this just to Helvetica. It's like a pet peeve or OCD thing or whatever. Then just flip it around. Maybe just do that. And put that in, transform it. Would you say, since this is now showing only interpolated frames, it loses spatial definition or quality? You would lose a little bit of quality, but kind of like Yeah, I would say you don't really have a choice unless you're gonna go like with a re-advection secondary simulation or something like that. So you're showing less quality the whole time, but like temporarily the quality is consistent. Like over time, the quality you're showing is consistent instead of bouncing around between like worst quality and best quality and worst quality and best quality or whatever. So that's what I was saying is like then you're re-ramping or you're remapping these fields. So that's boosting any like subtle changes that you're getting as you go from low quality to high quality frames. So yeah, if you don't really have a choice, like if you were just doing it for a still and you needed to do like, you just wanted to grab like a specific frame or something, you could do time blend and you wouldn't need to worry about it. But yeah, that's the idea. So I'm gonna do this to $FF. I think my merge method here, I just want to do a different way of time blending the font node. You have to be a little bit careful because like if you try to time blend it like this, it will try to do like vertex order matching and stuff like that. So I'm just going to do a time shift here. We'll say anytime you're doing a custom like scaling of time, you generally want to use this equation. So you want to subtract your start frame to get yourself at the origin or like 0. And then you want to do your scaling or your time speed multiplication and then just add to do the offset again. So it's like if you're transforming stuff in 3D space, you set your pivot to the origin. So it's the same idea here with this. So I'm just going to copy that parameter and do relative references. So if I play this, now we're looking at the frame number at half speed. And then I think I can just merge this. Whoops. Just pop this in with the other stuff. And I was doing something here with this. Let's put it over at the edge of the frame. All right. So I did something wrong here. Was this one not showing? Oh, okay, it was working. I don't know why I thought it was messed up. It was like flipbooking faster than I could see the decimal frames. Okay. Sorry about that. We've fixed it. So you can see a little bit of the difference here. This is a little bit more visual of what I was trying to explain. So you're going from a integer, or like this is the raw. Anytime it's an integer, then it doesn't need to do any interpolation or remapping because you've saved out your frames on integers. And then it does a 0.5 or a blend between forward and backwards frames or whatever. And that results in a little bit of a value fluctuation or just artifacts. And then over time or temporarily, you get some flickering because you're going from perfect results to like fully maximally like interpolated results. And then at the top, we did our time offset of the quarter frame so that we're always the same distance or the same interpolating the same amount. We're always the same distance from a perfectly good result that we're reading from disk. So if you do get some strobing, this is a little bit of a trick that can be helpful. It's like, doesn't cost you anything in terms of performance or file size or disk usage or anything like that. It's just a little hint or a little bit of a gem. All right, so I'm going to bail out of that one. Could just do a comment here. Say, offset by 1/4 of a frame to make sure you're always displaying equally interpolated results. Okay. And then the last thing down here with this Pyro look node, looks like it doesn't want me to do this twice. Either that or it doesn't. All right, let me just do this a different way. So I think if it's not gonna like that. So then additionally, like if you do this Pyro look node, which is another result getting put on top of the ramps or the interpolated values, this is another case where you just want to make sure you're not bringing out or like exaggerating any internal differences in the fields or in the volumes themselves. So for flamethrower stuff, I was finding this Pyro look, the new node 18.5, super useful for doing like this. I didn't have any specific references. There's what is the one movie? It was like one of the Transformers. I think it's this one right here, Age. I don't know the series that well. This one right here, this frame, you can kind of see it a little bit. They're doing some similar stuff to like mask out or to bring out some detail from the smoke and then the actual temperature. It's like slicing it or using the density as like a mask to hold out some things. Some of the Star Wars ones you could see it in pretty nice. Let's look at maybe Rogue One. Yeah, I don't know how many I can find here. There's actually the guy with the flamethrower, right? These ones are all practical, I think. Yeah, so most of these are practical sims. Sometimes depending on the way that they've created the flamethrower, they've just overexposed everything. They don't have as much control over it. What was another good one in Aliens? This is like a classic one, right? They have a little bit of that kind of seeing the holding out, like occluding some of the brightness with the smoke or whatever. All right. So we go back into here. You could see again with the offset, just a quarter of a frame, smooth out a lot of the flickering or strobing. So if you can, this is a good thing to do, is this one. And then if we go back to just the voxel position one, this one, of course, you basically don't have any motion information between the frames that you're interpolating, so it's always going to look very steppy, because it just can't predict the direction or any information of like where things are moving in. It's basically if you're coming from like a compositing background or using those plugins like Oflow or Twixtor or stuff like that, those are more like using the velocity field, a vector field, to interpolate or advect things. And then this one is like, if you basically just did like no frame interpolation or whatever in your After Effects or video editing app or whatever, you would just get the crossfaded, like just linear interpolation, sometimes is what people call it. So then another technique that can be useful, I'm going to use a regular ROP geometry output for this. And for this one, let me just actually make a copy of this. And this one, we'll just call it version 2. It's going to go in the same place. And for this one, I'm not going to export the velocity. So we'll just have density and temperature. Flame, I'm not using the flame volume, so I don't need that either. Could turn off color as well if we're not using it. And then for this version, I'm going to turn up the global substeps. So global substeps, the idea is that they're the same. If you're used to using DOP networks, it's this substep number on the top level of the DOP network. That's the reason that they call it global. If you go into solving, then these substeps here, these are what gets set internally, like on the Pyro or smoke solver or whatever you're using. And if you're interested in retiming, these substeps here aren't really that useful because you can't access the interpolated frames in SOPs. You could only like bring in frame 1 or 2. If you do a global substep up here, then you would actually get like 5 decimal frames or whatever, fractional frames that you could save out and cache like as their extra frames. So if you know that you're going to be retiming something, an easy way to just save out more frames than you need is increasing the global substeps. So this is more if you've used cameras with like high frame rates, this is kind of the same idea. Like if you're shooting like 120 frames per second, or maybe 8 would be like 240 frames per second or something like that. I'm just using this as multipliers of like 24 FPS. And then we have the substeps. So if you want to save them out, you'd take this parameter, the global substeps. Yeah, the result with different substeps can vary wildly. This is more of like in the future, if you're setting up sims that you know will need a retime, or if you're using GPU, sometimes I'll build out extra substeps like from the start, just because you don't get a ton of performance hit. And you'll know that you have more flexibility in the end. So yeah, if you're interested in like fixing things in the quickest amount of time possible, you already have a good result. These methods can be a good way to go. This is more of an approach that you would need to use like ahead of time, or you could try it out and see how different the results are. So for my frame increment here, I'm just going to do 1 divided by the number of substeps that I set up here globally. So we're doing a frame increment of 1/8 or 1/4 of a frame. And then if you're saving these out, this $F4 won't be that helpful anymore because it's the integer frame number. So you'll be saving frames over themselves. So if you want to fix that, you could do, let's pad 0. So this is an expression that's doing the same thing that $F4 was doing. The first argument is the number of padding, so 4, and then you can use $N, and this is a special variable, or so special like HScript variable that you can use only for ROP geometry outputs or render any ROP nodes, because this is a digital asset. You can't access the $N. You can access it on the ROP geometry. It's basically just the index number of the frame being saved. I think they explain it a little bit on the help card for the node. But if you're ever writing out like substepped data, this one can be a useful way. Instead of like, it can be tempting sometimes to try to do a bunch of math to divide the frame number. I've tried that before, and sometimes I'll get like rounding errors and stuff like that. So I've just found over time that this is a pretty simple way to go. You don't have to do as much math or thinking about things. So this, let me just look at ROP geometry. I don't know why this link, all right, is broken with the thing. So here it's just saying N is frame being rendered. It's not the best explanation. I think I don't know if maybe on just the mantra node or something it was described a little bit better. Let's take a look. It's hidden. Maybe they don't have it. All right. Let me do one last look at a different node. Maybe this one, it's like really old. So this is a little bit more helpful. It always starts at 1. It's basically just index number. Every time it saves something to disk, it increments by 1. It will always start at 1, and then depending on your increment, just every item, every file, every geometry it's saving, it will just increment. So you never have to worry about it overwriting itself. You never have to worry about decimal, fractional frame numbers. Like if you have a file path, like sometimes if you have a rounding error that's a little bit off of 0.1, it goes like 0.00009 or something, and then reading it back in can get yourself into a mess or whatever. So we should be good to go with this one. We'll just save it again. Do a save to disk in background, and should start seeing these come in a little bit. And then when I'm reading these back in, you can do this same expression. When you're reading it back in, you can just replace this with $F4 if you want. This OS, you'll just have to manually copy and paste it. Sometimes I'll do the op name with a relative path. And then this way, if you rename this node, it will update you don't have to worry about it not like updating the expression. All right, so it's saving some frames to disk. So you can see these still look like frame numbers, but we're basically just saving, it's incrementing like 8 times per frame. So if I play this back, because of the sourcing, there's a little bit of the steppiness. There's maybe something I would want to change with this pop network. It's just one substep. So if you really want a perfect result, you probably want to split all this stuff over, and you would want like maybe just 10 substeps or something like that to be safe. Sometimes if you just sync these up, that can work out well. You're just certain that you're always having your substeps match up and you're never doing like any interpolation that you don't need to do. So I'll just kill this one. It looks like it was already done maybe. And save this. Just fixing that issue. So we're reading these back. That stepping issue there should be fixed in a little bit. If you don't want to, you can see everything now is playing back super slow. If you don't want that to happen, you can do another time blend. Whoops. Time shift. So this one, I'm going to use it to speed things back to like real time. So we're playing things back right now at 1/8 of the speed because we've set 8 global substeps and we're saving 8 frames per like one real frame. So if you want to go back to real time, we want to keep using this equation, this frame -1 to center yourself at frame number 0, and then do your scaling. Doesn't make a big difference here if you're starting at frame 1, but some studios you start at frame like 101 or 1001 or something, and then if you don't offset it back to the origin, you can get into a bigger issue. Even at frame 1, though, it does make a small difference. So in this case, we want to get our substeps and just speed ourselves back up by those substeps. So this would actually be playing back now in real time. It looks like here, did these things ever finish? Looks like they're still saving out. Okay, yeah, it's still going. So this one is going back to real time. Usually I'll turn off that integer frame. It's just a good idea when you're blending and stuff. You never want to like lock yourself into integer frames. Before you do this, if you do your blending here when it's still the frame number like 1, 2, like the integer or the steps, you can do the blending. This time you could usually get away with like voxel position. So I didn't save out the velocity field, but we can still do a blend based off of the voxel position or just a crossfade between the two frames. And then if I do another, so this is our interpolation. And then you can do one final time shift that would be your remap. Tmap, remapping. So this, you do like the matrix bullet time or some type of curve like that. Let's do 25, 1, 26. So I'm just going to set a area that's like really flat. So if I shift click on this, you kind of see what I'm doing. Just any time that this curve is getting very close to being completely flat or no slope, that just means it's not, time isn't increasing at all. And then I think I've, just make sure I got all these with no integers. Should be good. So the idea is in that super slow-mo or like bullet time part, you're doing the crossfading like that, but it's not a super big deal because you've already saved out so many subframes that looking at these results, the difference between the previous and the next frame is never super drastic. So if you need to push and really interpolate between these steps, you can do it using the voxel position. You just say this is like a linear frame interpolation. You can get away with pretty big time stretching that way. I don't know this Pyro look. This is one of the situations that I think you guys were talking about with different substeps. It can start to throw off your overall results. So like this is getting a lot fluffier. That's just something you never really have a ton of control over. Basically, when you add more substeps, you're doing more pressure solves every frame. So even if you've compensated all your values, like your time speeds, your substeps, like you've compensated all your sources to be only adding like 1/8 of what they were adding every frame or every solve, you still get a different result because the solver is doing more pressure solves, so you'll get like just different shapes and stuff like that overall. Let's do this one and compare it with the non-substepped one. Okay, so just don't do the interpolation. So these should match, but because we're doing more solves here, like the cooling rate is a little bit faster at the bottom because we're doing more substeps. So we're doing more times that you're applying the cooling. There's just always going to be like rounding errors or little things that will happen between the frames that you'll get different results essentially. This stuff has been getting like better. They've been balancing more of the parameters. Like the actual behavior is pretty similar in terms of motion. Sometimes in the past, or if you set up stuff like manually, you might see that the overall motion is even very different. So that's one of the reasons I was saying if you're going to go this route of doing extra sub steps, it's best to just like figure this out at the start of the shot. If you're working at a studio and they say this is going to be a slow motion shot, or this is going to be like a hero flamethrower thing where we want the camera to even go all the way to like no speed at all, then this is a situation you could think ahead and kind of set things up this way. So let's just, I don't know if it's my radii. I guess that's a little bit better. This is starting to go pretty slow in terms of the actual simulation. It is just a pure CPU simulation I'm doing with the sparse solver. But if you do have the ability to use a GPU solver, this can be a lot quicker because it's basically just you don't waste as much time doing substeps if you're simulating on the GPU. It's a lot quicker. All right. Let's make that brighter. Maybe do like less smoke. Seems like the flamethrowers usually just don't have too much smoke in general. When I was looking at some of those references, it was like purely just brightness or gas, but I don't know. I think it looks cool. You add some detail with the a little bit of smoke, kind of like adding some negative space or whatever. All right. So we can take our remapping curve and let's apply it over here to that one. Sometimes these there can be an issue if you ever have more than one, you're merging together two different Pyro visualizations. The reason that happens is because it will store all the visualization settings as a detail attribute. So you can only have one visualization setting. If I switch between these two, it just would take the visualization settings in terms of like ramp values and stuff like that and use them globally. Demon Case, how's it going? We're doing some Pyro volumetric retiming, a somewhat deep dive. I'm doing all right. Yeah, this was TM13's question, I think, in the Discord. So we started out up here, this top one, we're just simulating at one substep, and then this one's using the velocity field to interpolate or advect between frames. And then this bottom one, you can see that the result is different. So I resimulated or did a new simulation with 8 substeps, and then not using the velocity field at all, but it has enough, it's enough of like a high frame rate that you can just linearly interpolate or blend between frames. You could see overall like the expansion, the disturbance, certain effects like that behave differently with more substeps. even if you try to compensate the strengths of them, you still will get different results just because it's you're applying more iterations of something. So you get a little bit, you get away from like the pulsing going this way. You get a little huge, you get a little bit, if you pre-plan and know that you set up your sub-steps ahead of time and just dial stuff in like that, that would be my advice if you know you're going to be needing to do like a super drastic timeline punch in or whatever like this. The sub-steps don't necessarily affect the retime. They're just giving me more frames to work with, essentially. So what I did was simulate. I don't know why this got locked. I think I might know, actually. So the sub-steps, the retime nodes, I think. Is this one locking me in at... Sometimes these will clamp your last value. It looks like as long as I don't have it on hold, it should be good. Might just be because the simulation doesn't have any frames, so it's just holding the last one or something like that. But yeah, what I did was I simulated at 8 substeps, and then I cached this out using an increment of 1/8, like frame increment. Every regular animation frame, it's going to save 8. It will save all of the substeps. So it's more like working with a high frame rate camera. If we take this, usually you shoot for film at 24 frames per second. Sometimes people will work at 240 frames per second. So that's, if we divide that by 10, then you're back at 24. So if you shoot at 240 frames per second, like on your iPhone, there should be an option for it. Some of the Sony cameras, they do a good job of shooting really high frame rates. That's kind of, theoretically, you're like capturing the world at 10 substeps. In real life, the results don't change because there's no substeps. It doesn't work like that. But conceptually, it's the same idea. Shooting 240 frames per second and then playing things back at 24 frames a second, you're doing like 10 times as slow, or you're essentially simulating or recording things at 10 substeps, if that makes sense. Let's see what happens with this. Both of these again. Yeah, I don't know why it stopped simulating. I have 513. That might be where it's just as far as the stuff has gotten to. It might also be my remapping curve. Yeah, I think that was the issue. So if you just forget about this extra stuff, there might be a way to extend things. Memorum, thank you for the tier 1. I'm using Mint. This Mint 20 Metacity Mate, Linux Mint Mate, if you look it up. Dual boot. Yeah, I have this one set to dual boot. It's super slow to reboot. I'm actually using a really old computer. Let me just add this other keyframe. So just manually set another frame to fully like extend things. We'll do one more. Old i3, it died. It's a bit of sad news, but I guess it's a good motivation to get to upgrade it. The i5 is pretty slow for working with Houdini simulations. So this one I have here, these Intel Xeon X5680. They have 24 cores, and the clock speed looks pretty good. But in reality, they're pretty old processors. It's like a really old refurbished workstation I had bought. So these are from 2010. It's like a 10-year-old processor that I need to do something about them. Memorum, thank you. Yeah, Ben, we're talking about, if you just came in, we're talking about retiming Pyro simulations, different approaches, whether you're just working with this is a sparse solve, just using the simple Pyro solver. My window isn't, could do it maybe in this one. So I'm just using the Pyro solver right here with, looks like I need to resize this window. All right. So yeah, I'm using this in the other scene with all of the exported volumes. I'm saving them as VDB with 16-bit float, and solving, I'm using the sparse solver and none of the OpenCL stuff. So yeah, it looks like the other one, maybe because I copied that same node over without fixing it. You can just take this copy parameter, delete this, do it as a reference. So yeah, up here, these are the solvers that I'm using. This just simple particle sources. I just did like a line with a direction or whatever, a little bit of gravity and stuff like that. And then the settings in here aren't super crazy. This is just more of a quick kind of benchmark test or something like that. It's still, I don't know, I'm not super happy with the results. They're getting there, but I think for a flamethrower, you get some better detail. The motion and stuff like that, some of it's a little questionable. How long it takes to sim this? For the first one I did at one substep, I believe it was taking maybe 10 minutes for 10 seconds of animation or 240 frames. And then the one that was with 8 substeps, I think it's probably still going, but it might be taking like 20 or 30 minutes. So we're talking about like retiming. That can be a big factor to think about sometimes. Like if you start working with really high res simulations and you're doing re-advecting of the fields like I'm doing at the top here, that can actually add a lot of time to like generate your new results or do those interpolations. So that's another reason I prefer to work this way for like really drastic speed retimes, really high res hero situations. It will just be quicker to render and to produce the final results. Anytime you're doing like a lot of post-process, you can talk about re-advection stuff in a little bit. The top results flicker in slow motion because I'm just interpolating between too low of a data points, if that makes sense. Basically, if you've simulated stuff without as much in between motion and you try to create too much of it, you'll get some flickering between the frames. I was talking about it earlier, especially if you're doing temperature fields and then remapping the values in that field to be like really bright and really dark with color variations. Any subtle change in the actual values in those voxels will accentuate or exaggerate the flickering as well. So if we just look at the results here, this one, I've just saved it out as integer frames with no substeps. So it's trying to stretch and create like 10 frames or 20 frames between these two data points or these two snapshots. With this one, I've saved it out at a higher frame rate. So you can see even playing them back, we have 8 substeps per frame. So when I'm interpolating between these, it's just stretching these two snapshots. And that's a small enough difference that you can use an interpolation just linearly, like crossfade between these two to smoothly like create as much, you kind of have like limitless speed you could play around with. Like if I really wanted to play this back, all back at like 0.01, super, super, super slow, you could do that pretty smoothly and you shouldn't see too much flickering or artifacts or stuff like that. So it's kind of hard to visualize, but hopefully that makes sense. All right. So yeah, if you guys want to get caught up again, just do another update of the scene that I'm working with. So just to keep marking things up, this will just be single substep. Just make this a bigger font. Maybe I did it too big. It's going to be confusing. All right. What the hell is going on? All right. And then this one we'll do 8 substeps. So we're basically doing high frame rate sim. Have you worked with the cameras or video editing or stuff like that? Or even like video games, this is like 96 FPS or something like that. It's just a much more fluid and smooth result. Working with that and additionally retiming it or stretching it out, you just have a better result. This one, we're doing time blend, advected, to blend between the two results using the motion information or the directional, the velocity field. But even that, you'll get some flickering and stuff. All right. So there's one more. I'm not going to go too deep into it. There is one more option you have. I don't think it's super easy to set up. If you look at container tools, they have a shelf tool up here called upres. I could go to bigger shelves if you're used to seeing them like this. So upres container, using this process, you can either do an upres of your smoke simulation, or you can also use this to retime or re-advect your simulation at a higher frame rate. So the idea with that is you're using your initial simulation as a source to do a new simulation. This one would put some nodes together, basically using this special solver called gas upres. It's still technically a simulation because it's solving, like it's caching with substeps and stuff like that, but it's using the existing velocity field and pushing higher or more information through it, or it's just pushing stuff through it at a slower frame rate. So you get you'll get results that more closely match your base simulation. So if you really need to go slower without pulsing, and you're really set on the look, then this can be the method to go with. If you look, I think on OddForce I've seen it. I think it's like upres sparse. Oof. Maybe I just need to do the .NET. Okay. So yeah, this information here is fairly new. There's some different threads about it, I guess. But people have put this together. I think the Bunker even made a tutorial. So we'll just put this as a link like that. So I try not to do this if possible. Because it just adds a lot of additional time. You're doing a post process to your initial simulation that's going to maybe take twice as long, or it could take 4 times as long, or it just adds an additional step that's going to slow down everything that you need to do. If your client asks for a change by tomorrow, then you need to do your simulation, then you need to do a high-res simulation. You're saving a lot more data to disk. It's just more things to manage. So if possible, I'll try to avoid this technique as much as I can. But this can be a good method if you just retime it and you set your time scale. I'm not going to go through it all because it's a pretty big thing to set up, but it's a possibility if you really need to do it. I would visit some of these OddForce links and check it out. So there's some files that people have put together there. So you get the idea with everything so far. Got some spelling errors here. All right. So there's one more thing we could talk about in terms of retiming. And that would be if you're going to treat your results as like a SDF or a distance field, like a hard surface kind of shape. Let's just set up a quick example here. So we'll start with a sphere. Do a DOP network. Just going to convert this to a volume. Can just maybe do ISO offset. This is just going to be an initial volume, so I'm going to be a little bit lazy with things. And usually, like in the past, you've probably seen me set things up with particles. Let's just do this pretty high resolution. Is this making a, I don't know what it's saying, calculating SDF. I just have it set to fog. All right, just make it smaller. I'm just gonna go the other way with this, I think. You do VDB from polygons. And then just set it to fog. All right, that should be good enough. We can do a smoke object, smoke solver. And this one I'm going to do it with the OpenCL. That's why I'm taking some more time to set things up a different way. Let's go the bigger dimension, the initial density. Just use the primary, the first input. I'm sorry. Start at 0. It's always a gotcha. All right. So I should be able to put in some turbulence, and we should see things moving around. Just make sure that everything is wired up. All right. So my idea here is just to set this stuff up, have turbulence moving this around, and then I'm going to be treating it like a SDF or a hard surface simulation instead of like a gas, and we'll talk about retiming that. Set up a simple animated volume, and I'm using the volume viz, but can't get it to render the proper color. How do I map density field to color diffuse in material context? Depends on the nodes you're using. If you're using this Pyro look node, they've set this up pretty nicely under at the top here. If you do create material, this should create a matching material or a matching shader that should have everything set up the way that you have it set up in the visualizer here. You do a quick, let's just do this next to it. Where did it go? It's inside of this node. So they do it with a hot link like this. And then that you can see up here that the smoke color is linked up. If you want to put this into a custom location, just matte, then it will create a shader there with the same links. But if you want things to match, I think this is the best way to set it up automatically so that things match, if that makes sense. If you're using the slightly older visualizer node like this, there isn't any convenient way to automatically like map everything over. So this Pyro bake volume is a newer node that they've introduced in Houdini 18.5. It does have this scatter stuff built in, but you don't have to use it. You would still use this like it's just visualizing or coloring the volume how you want it to be. Could add fire if we want. So inside of this, if we go into kind of the hidden area, this node is all built around, they're still using volume visualizer inside of it. But this is just a more convenient kind of all-in-one like Uber functional node or whatever you want to call it. You do your visualizing with these higher level settings. It can manage like AOVs or extra render layers. If you want to bake the emission into CE, this can be useful if you're rendering with like Redshift or stuff like that. And then it has these macros at the top. So if you're interested in doing that kind of stuff, I would recommend switching over to this Pyro look, and then you can get materials and stuff like that to manage them that way. Here, this is where it created it, all the way over here. So it can create little material networks, and all of this stuff should get automatically, like it will, all these references will be created for you, so it's pretty nice. Okay. So when I'm working with OpenCL, putting off updating. Yes, so in older versions of Houdini, they had ways of synchronizing the Pyro look, but this is definitely worth the upgrade, I would say. On the Pyro solver itself, under look, there's a button here for create matching material that you can use as well. But I think it's set up similarly with Pyro Bake, in that you wouldn't be able to like apply this to another visualizer. So if I do this, it looks like they've set this up similarly. I guess the parameters here aren't linked automatically, but it's another way if you want to create a shader to render with that would match your Pyro settings. So that's just on the Pyro solver. Under look at the bottom of it, it's kind of hidden. There's a create matching material. And by default, it will automatically like assign a material that's matching the settings. I think inside of the, somewhere hidden inside of this, they have a material network. I don't know if I'm gonna be able to track it down. They're good at stashing things all over the place. All right. So working with OpenCL, I turn it on, and then I try not to cache the substeps or cache any of the simulation to disk if I'm using OpenCL. So if you go to creation, you can turn off allow caching here. This is the same thing as turning off the cache at the top. Then you want to make sure every node that supports it, you're using OpenCL. And then if you go up here, the top level, you can pin your viewport, get the density field, and convert it to VDB. These are the similar steps that they're taking when they have the minimal OpenCL toggle. They'll do these steps automatically for you. So now when I'm playing it back, super quick to get the results. Let me just make sure. Might just be because I'm working at a lower resolution. Sometimes there's some transparency. It looks like it's not super different. All right. Might just be because I have like a lower resolution volume. Let's just fix that. We'll go here. We're working at like 300. And when I'm converting this to, just turn this off up here as well. When I'm converting this to an SDF, you can just do it with another convert VDB. We're going to be keeping it as a VDB type, but the class will go from fog to SDF. You can see that there's like some faceting, and that will just happen because we're using this primitive type sphere. If you switch it over to polygon, and then you manually like up-res it or increase the frequency, then you'll get rid of that faceting. So if you want to time blend or interpolate some of these results, you have a little bit more tools that kind of like flexibility, because the way that these fields get represented, if we slice this just to inspect the values of things, we'll get no mapping. So this is the actual distance to the surface. You have positive values for the exterior, negative values for the interior. So when you linear interpolate using time blend, it's easier to move the volume from one position to the other because you have these distance values that you're interpolating, instead of if we just look at it this way, if you try to blend, it has no idea like the distance from the surface for other parts of your volume. So when you blend it just as a fog volume, you get more stepping or more flickering. If you interpolate distance values, you'll get smoother blends or smoother results. This is an advantage to surface SDF volumes, but the drawback then is that it's just representing like a uniform volume inside of it. So like you can't really use this technique if you have a fire volume or something that's, it has like intensity or different values inside of it, if that makes sense. So let's go into here and maybe we want a smaller scale turbulence, higher frequency, and more features, more bubbles and stuff like that. Maybe the pulse length will make it slower, and the scale, just make it a little bit faster. I don't know if this swirl size, I'm going to make it a little bit lower. And then on the advection tabs, I'm usually a bigger fan of doing these BFE, CC, and trace Runga Kata 3. They're just more accurate methods. They might be a little bit slower, but with OpenCL, you don't have to worry as much about performance hits or stuff like that. All right. So we're doing convert to VDB. If you want to do the 16-bit float, you can use that just from the primitive SOP. So this will reduce your file size because it will save these as 16-bit volumes on disk. And then this one will just be like a just call it SDF Retime Sim, and should get started. If you want to get caught up, we'll do another scene. Might be a little bit messy. I've been making, just putting materials everywhere. Just get rid of that. I'm going to make a light at the object level. with the flamethrower, it wasn't a big deal to have if you want a light or not. Because my smoke was so dark, it wasn't really going to catch too much of the light. And then the flame, that's all like emissive volumes, so it doesn't matter with the light. But if you're displaying a simulation at the SOP level, depending on your opacity or the thickness of the smoke, you can also change it with the primitive SOP and change the visualization here. So if you're getting like darker areas, you can just make out the form of it a little bit easier if you've added a light at your object level. Let's see. So this is a GPU sim. It's pretty quick to get all the, looks like we're getting 20 or 30 frames per minute. All right, so we're converting it to the SDF with this node. You might want to do a smooth SDF operation just for beauty reasons or whatever, like if you just want the results to look a little bit, sometimes if you don't smooth it, you'll get some actual like grid artifacts or whatever. I don't know why that thing is lighting up like that. Smooth is just pretty much a blur of the volume. Sometimes these other methods can give you, preserve the sharp features a little bit better. And then I'm just gonna reuse this remapping curve, but we'll put it after a time blend. We'll leave this at a voxel position. And give it a try. And then after we do our time blending and remapping, for the very last thing, you can convert it to polygon soup if you want to actually see like the hard surface representation of things or whatever. So this would be if you're doing more like abstract forms or something like that. Let's just get rid of the last flipbook and we'll do a new one. So we're using the same time remapping curve or the same expressions, same animation like bullet time effect that we were using before, but it should hold up better because we're blending an SDF. So because we have the distance values in the field or in the voxels, we're visualizing them with this volume slice. You can create subframes or blend between things and avoid a lot of the stepping, because you actually have distance information that you're blending instead of like blending between alpha channels. Like you just, instead of just having the outlines and crossfading between them, this is more kind of blending like coordinates or the distance itself. So you can have a bit more flexibility with doing retiming of this information and get smooth results this way. So we don't have any velocity field. We're not doing velocity-based advection. We haven't done crazy amounts of substeps on the DOP network. We're just doing one substep, but you can see we're getting pretty drastic retiming, but we're not getting a lot of pulsing or flickering or stuff like that. All right, so we'll do maybe reduce this ISO value just to get even like blobbier, fluffier kind of forms. This simulation finished. Might go a little bit higher resolution. Do a bigger swirl size. Maybe more turbulence, but less grain or less roughness, just so you get like a little bit more detail in the turbulence. And we'll do another. So it's slightly higher resolution with this one. Might still be taking some time to spin up in the background. All right, looks like it's going. So I was just doing some tweaks there to get a little bit more detailed of a form. If we switch between the two sims, you'd see a little bit of a difference. Ooh, this is already up to 84. It's still going pretty quick, it looks like. Let's do our one more remapping and see what happens. All right. So again, we're just doing this by voxel position. And if you're interpolating or blending the SDFs, it works more like a morph or something like that. Is just is a lot more smoother to do blend shapes between an SDF volume than two fog volumes, because you have the distance coordinate that you're using to blend between things. So yeah, a lot of this stuff, it just depends on your situation, what you have to work with, which technique you want to use. Sometimes if you're doing abstract stuff like soap or really specular volumes or really viscous kind of slimy stuff, you can use this SDF rendering technique, do like subsurface scattering or stuff, and get interesting results. Ooh. Thank you, Steffi Fung. Yeah, we're doing a ton of stuff today, just retiming volumes, different types of volumes. This one I'm doing it more of like a hard surface. This is like called the SDF in Houdini. but it's just using the VDB tool set. Retiming it. What I'm doing with the retime, it's just working with the cache here, and I'm just doing the matrix kind of like bullet time effect. So there's an animation curve, but basically it's just kind of like that at the start is like retiming with After Effects or Final Cut Pro or Premiere or whatever. But yeah, it's just to add some like dynamic excitement or anything like that. Yeah, slow-mo and then back to real time, like bullet time. I don't know, this overused Hollywood Michael Bay kind of. I don't know if Michael Bay uses it or who's most famous for it. Yeah, there's other. I did a high frame rate kind of technique earlier where I was just simulating something with a lot of substeps. Zack Snyder, he's the slow-mo king. The matrix rigs are really cool if you look at some of the actual ways that they shot it in that time. Like I think they use a lot of SLR cameras that were on like a rail or like the motion path, and then they all clicked or fired or whatever. Every motion design studio does this. Yeah, this is a pretty, you just make endless, make a bot that will post this to Instagram, make a script that will post something every hour. But yeah, there's cool things you can do post-processing it, like doing fancy shaders and stuff like that. Yeah, it's super technical at the beginning. I was going through all the different things, but just with volumes. So like Houdini, they give you a lot of flexibility for retiming stuff, but just because there's so many different data types of like particles, alembics, rigs, volumetrics, you might have like changing point counts, or with volumes you have like changing voxel counts. So there's just a lot of technical nonsense you can get into with your retiming stuff, but you spend the time to get everything right, you can get really cool results. There was a wine glass thing that I did a while back. That was like RBD, pretty heavy like RBD constraints. And then this one I was taking similar like precautions or planning ahead to get, be able to punch it in and just get even like kind of have infinite substeps if you set up things right. Like you could dial the frame rate back to be like 5,000 frames per second or something that will still look smooth. I don't know if I pushed. I was looking at some references, but it seemed like even super high frame rate cameras, like the glass shattering was still happening over 1 or 2 frames or whatever. But yeah, I took some artistic like liberties or whatever just to try to make it more interesting. So yeah, with this one, this is the animation curve. So just like your video editing software, whatever, volumes, they're kind of like pixels, but 3D pixels or voxels or whatever. So you can retime them just like you would an image or whatever. I was going over other techniques that will give you like little things to work more like OFlow or Twixtor or stuff like that if you're using the motion information to smoothly retime them. So let's just do maybe some quick fun stuff to play around with the visualization of this, and be the last thing for today. So if anyone has any questions or stuff like that, feel free to drop them in. So one thing with these, you don't have UV coordinates. You don't have really positions. Like if I try to do a noise based off of the position, you'll get a classic kind of swimming texture where the positions of the noise is fixed, but your point positions are shifting or moving through it. So you get the swimming texture, whatever. Like this stuff isn't stuck to the volume. So it's a bit of a shame. Let me just do something here. So you can do maybe the color transform. This is a cool way to make color ramps. You basically set up your color information in another color space. The hue, saturation, luminance is a pretty typical one to get started with. So the noise, we can have that drive the hue, and then the saturation and luminance, just set those to 1. We should get something happening. I don't know if it's too. I think my noise value is just too high. All right. As you kind of get like iridescent looks or stuff like that. But I'm just going to get away from the retime, so this will play back a little bit faster. So over time, you can see that the noise pattern is like stuck in 3D space, but the shape is moving. So it's a bit of it's not going to look that good. But one thing you can do is generate your noise based off of the normals. So these will kind of look like they're moving with the volume, because over time, if we go to the smooth result, they'll look a little bit better. You can also do some stuff with them explicitly to smooth them out even more. If we assign normals, you can blur them or smooth them. Then get rid of some of those other artifacts or whatever. Let's do this. Maybe a lower frequency. And just do another flipbook. So because the normals are based off of like the direction the surface is pointing, that information is more cohesive over time, or it's more like stuck to the motion of the simulation. So if you do a noise based off of the normals, you can kind of get a cool thing that will stick to your it will look like it's complying or behaving like it has the same motion as your simulation. So it's another cool trick you can do with the SDF stuff. Again, you don't need to keep rest textures or like simulate a bunch of extra information. Just a bit of a hack. And color transform is one that's pretty cool. Another thing you can do is just like chain together some noises. So this first one is doing a broad low frequency noise, and then generating another noise just based off of the changes in those values. So let's do something a little bit brighter. Maybe a little bit less roughness. See what happens. Some of this stuff I might have had it too high of frequency or too rough, but visually, because this surface, the surface direction is moving along with the simulation, then your noises will go along with that, if that makes sense. So if you're interested in making crazy abstract, super marbly simulations and stuff like that, you can do a lot of these things kind of for free, or I'm saying for free because we're not using the velocity, we're not doing extra like texture coordinates or extra saving a lot of crazy stuff to disk, but still getting all the features of like being able to retime it or texture it in abstract or interesting ways. You can, just gonna do one more simulation with a little bit more detail. Oof, something crashed. Oh no. Might have been too much information. Studio Not War, thank you. Yeah, sorry, it just crashed there at the end. Should be able to get back into it pretty quickly. The crash always gets me. Where am I? Yeah, Houdini does a good job of, it will do this autosave as well. So even if you're crashing it, it generally does a pretty good job of saving those results. I have like a thing from my shelf tool that can pull in the crashes. Is this one might be the wrong one. It's a different crash. But they'll just go into your temporary directory. Or they should. Xanders, how's it going? Maybe this one didn't go in. Whoops. I think I saved anyways, so I'm good. And then it does look like even my simulation that I was doing in the background, it did get launched, so it's still running anyways as well. Unfortunately, my window positioning didn't get saved. It's like the curse of Houdini. Sometimes it's not very good at saving your preferences. Oops. All right. So how to open PDF. Can't do it. There we go. So this is simulating the higher resolution one in the background. I might have just cranked things a little bit too high. But it's going and it's definitely working. So we should be able to play back or start playing with some of this information. Ooh, Atrava. All right. Might be this blur. This blur will use OpenCL stuff, so if you try to run it at the same time that you're simulating on the GPU, it can crash you. These bots, they've been using a new technique where they use a lot of these like Thai font types. Is that the Thai font? It's like the Thai font characters or something. I don't know. The bots are always one step ahead of you. The bots are brigading. You can hear the GPU fan. The bots are brigading the GPUs. They're hoarding all of the resources. So I think I probably have saved enough of these. Just gonna kill the background stuff. We should be fully optimized with performance now. So I'm just going to turn the smoothing back on. And just fix a little bit of that like flickering. Let's do this, like less roughness. You have to be a little bit careful because it's easy to generate like noises that are too high of a frequency for your geometry. So you'll get like aliasing or artifacts if that is the case. See what happens with this. Yeah, these look pretty good with metallic shaders. I don't know why this, I don't know if this HSL is like a different order than I think it is. Pretty sure that this first input is the hue and the last should be luminance, like the brightness. Maybe it should be like 0.5. And then these values now are just too high of a range for it. So if you work at a lower amplitude, you can get just a subset of like the color spectrum. Just get some Taco Bell, Baja Blast brands happening. This is just I wanted to do the multiply add constant. And then if you do add, you can shift through the color range or whatever. So yeah, you could do these stuff in the shader. You can also, oops, just get rid of all this. One last thing you can also do is use it like a displacement value. If you do displace along normal, it's possible. Let me just do it this way. I'm just going to put this into color. I'm just going to recalculate the normals and do another VOP. Because I don't want to like displace along the blurred normals. I want to displace along the actual. To do color, displace. and then you can do one more normals. You move them, so you want them to be different. Just want to recalculate them after you move them. And I'm going to get rid of the color. And we're starting to get some interesting deformations. It's possible here, if that's going inside of itself like that, you might want to use the absolute value so that it's only a one-way displacement, like outwards. You could try like some different offsets, different positions or whatever. All right. Sometimes for this, somewhere in here, if you do a subdivide, you can get a little bit more like smoothing or whatever. All right, so we're doing this after the retime and after the interpolation and everything. We'll just do, I don't know, we could get, I'm going to flip book it in a second, but just going to add a color at the very end. Somehow this got into the black end of the color spectrum. What have I done? I don't know. I might have broke it. Should be working. Just keep going like this. Yeah, I think it's working. All right. So we got our slimy blobby thing, and we'll do one more flip book with this. I added too much. You think it? I was thinking it should wrap around, but it's like it should just keep cycling. But it's possible I did get out of the range. I did do too much. So yeah, there's plenty of different options here to try out, to play around with, but can get some really cool. The hue shift recycles. Yeah, the hue shift, there's also This C transform one is nice because you can try out some of the other color spaces. You have more options, like doing temperature, lab. Some of these other spaces you can get some funky like alien looking things. So there's hue shift, and then there's also like HSV to RGB. This one I'm pretty sure will definitely cycle. If we do this and go back to that one. But you're just limited, you can only do HSV. I think it's a little bit different where this one is definitely brightness, middle one is definitely saturation. But yeah, you can drive it with a hue shift as well. Something is cooking. So yeah, there's a few different. Just gonna go with a lower multiplier, and then I'll usually just add to get to a different different portion of a different gradient of the color spectrum or whatever. There it is, the Baja Blast. Blobby, the blobby thing. Let's just do this one with a lower. I think the subdivision is just a bit too slow. There's too many steps that I added in here. Let's just do a lower frequency blobby type of pattern. All right. So yeah, the nice thing working with these SDF VDBs is that you can derive a lot of this information for free. So the time blend, we have it going on, and then because we're doing all of these other effects based off of the normal, this will all follow the same. You don't need to worry about like blending other UV textures or rest coordinates or stuff like that. So it's a pretty cool idea. So we did some practical stuff at the start with the flamethrower, different smokes and stuff like that, how you might want to retime them. And then this one at the end is more for abstract effects and just some ideas and stuff like that you can play around with. So yeah, if anyone has any questions, we can wrap things up. Log off in a minute. Hopefully people found this useful. It's a little harder to stream this kind of stuff just because it's so slow to like generate good looking things with high res like simulations and blend it together and stuff like that. Yeah, I'll do another updated share before logging off. Yeah, I think with volumes it seems to be the most technically tricky or whatever. Like, there's just so many different ways to approach it. But with like RBD stuff, it's a lot easier to retime that because you have the transforms, the quaternion or the packed transform. So you have a fixed point count, so it's super easy to interpolate. Just 2 points in space, you do an interpolation between the two of them. And then for rotations, because you have that stored as like a matrix or a actual rotational value to blend or slurp that rotation, you can get like really good bullet time or slow-mo RBD sims without a ton of work. But volumes to me is always the trickiest of like in terms of just different approaches for different reasons and then different technical limitations and stuff like that. But yeah, it's pretty fun to play around with. So we'll do just restructure this a little bit better. Whoops. All right. So the idea here is if you're blending SDF volumes, you get really smooth results without having to worry about doing the velocity advection or super high frame rate, high substep simulations. And just again to touch on it a little bit is because these are actual distance values or distance like coordinates. So if you know the previous and next frame and you're trying to move where this crosses 0 from positive to negative numbers, it's easier to move that between two of the different values. If you're looking at it when it's just a fog, so that was just smoothing it. So when things are just a fog, this opacity or this value is more meaningless. It's just the visual thickness of the smoke. So it doesn't indicate anything about where the surface is or anything like that. But if you convert it to an SDF, this is more of like a coordinate system or a value that is more meaningful, that to blend it between two spaces, you can do it much more smoothly. All right. So yeah, these are the options: readvection, high res, up res, single substep, do it with velocity, advection, or just doing it by voxel position is not very good. It's very steppy, very flickery. And then if you plan ahead or you have a specific shot that calls for it, you can simulate things at a super high substep. It's like working at a high frame rate. If you don't want to do that, you could also like just scale the time and work at like slow-mo or whatever. It just depends on your workflow and stuff like that. And then for SDF or abstract stuff, you have the additional flexibility here, just working by voxel position. So yeah, we'll do the final scene share for today. Some fun, different things to play around with, flamethrowers, expanding blobs, smoke, fire, and I don't know what you want to call the last thing. It's kind of like a cloud. It's a bit of could be like the Akira sequence or whatever with the thing that attacks him that's like keeps growing till it fills up the whole city or whatever. But yeah, it's a fun time. So yeah, we'll be back Friday with the Cool Zone, another one.